Yeah. Okay. Um, let's speak about typical goals. What we do with ETS model. Normally, what do we do with ETS model? We basically we have two goals. We have forecasting goals. We'd like to predict one step. We'd like to have one step ahead forecast, two steps ahead forecasts, and so on. And we'd like to make seasonal decomposition. Sometimes to interpret, to make some. So, for example, you see that YT has augmented from the previous one substantially. And basically, you would like to understand whether this is due to seasonal effect, or maybe this is due maybe this is due to growth rate change. And this goal is also has some. This is also a honest goal to decompose time series into components. Okay, for the moment, I will skip estimation step. So imagine by likelihood, by maximum likelihood miracle, we have 9 parameters estimated. We have them. So for the moment, just imagine that 9 parameters. So what do we have? We have a time series. We have observed values. So what do we have? We have observed values. So it's y1, y2. Let's say we have 100 observations for simplicity. So we have observed value. So then we use maximum likelihood magic. And we will not discuss this magic for the moment. And we have 9 parameters estimated. So we have by this maximum likelihood magic, we have alpha hat, we have beta hat, we have gamma hat, we have sorry, hat gamma in LaTeX. We have L0 and so on. So we have 9 parameters estimated. I don't care about that. Magic. I plug in into computer and I have 9 parameters. For the moment, let's ignore it. We will delve into details, but not for the moment. Okay. You have, so what is the problem now? The problem now, we have 100 observed values. And we have by maximum likelihood algorithm, we have 9 parameters estimated. So we have complete specification of a model. And now let's decompose. So how to make seasonal decomposition. So first, let's say a miracle. I don't discuss for the moment because it requires let's get used to the model and then we will discuss how it's calculated. Well, let's do like that. First, we discuss how we make seasonal decomposition, how we make forecasts, and when we are used to the model, when we understand it better, we can speak about technical details, how it is estimated. Okay, for simplicity, I will omit hat. I will omit hats. So I will say just alpha, beta, gamma, not to write. I will omit hat above estimated parameters. Estimated parameters. So I will think of true values of parameters. In real life, they are always estimated. We cannot have just alpha equal to 1 over 2. Alpha hat is equal to 1 over 2. We can estimate it. But for simplicity, to discuss how to make seasonal decomposition and how to make predictions, for simplicity, I will omit hat above estimated parameters. I will just say alpha, beta, gamma, L0, L0, and so on. So let's imagine that. So let's imagine the some observed value. So let's imagine some observed values. Let's imagine that y1 is 101. Imagine that y2 is 104. Imagine that y3 is 106, like this. And I have, I will simplify for simplicity. I will speak that I have true parameters. I have true parameters, but in real life, we have estimated parameters. So let's imagine that B0 is 2. Let's imagine that L0 is 100. Let's imagine that S0 is 1. S minus 1 is 2. S minus 2 is minus 2. And that's all. Okay, my question is just decompose y1, y2, y3 into error, seasonal effect, and trend. So my question is decompose y1, y2, y3 into error, trend, and seasonal effect. So I have observed values. I have true parameters. In real life, I don't have true parameters, but I have estimates of true parameters, and I work with estimates exactly in the same way I work with true parameters, so that will not change our calculations. Okay, let's look at, let's copy. Let's copy our equations. Let's copy our equations. Sorry, I need more parameters. Sorry. I need alpha. I need, this is parameters without noise, but I have noise. So alpha is 0.2. Beta, let them be equal. Alpha, they are not necessarily equal, but to simplify calculations, I will say that every Greek letter is just 0.5, and because I need to show you how to calculate, but I'm not interested in the exact result, and sigma is 2. Okay, now I have true parameters, all true parameters. I think all 9. 1, 2, 3, 4, 5, 6, 8, 9. Sorry, 1, 2, 3, 4, 5, 6, 8, 9, 10. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 7, 8, 9. Okay, yeah. 9 parameters in total. Okay, let's decompose my three first values into three components. So this is a copy of equations. This is a copy of equations. And now so what does it mean to decompose into error, trend, and seasonal effect? So what do I need to find exactly? So in other words, that means find L1, L2, L3 that will be deseasonalized. Find S1, S2, S3, and we may also find B1 growth rate, B2, B3. We may find U1, UT, U2, UT. So we will find true decomposition in real life because we don't know true parameters, but we have estimates of the parameters. So we have estimates of these effects. So, but in my case, for simplicity, to avoid writing all this hat, I will pretend that I know true parameters. Okay? Any questions up to moment? Can you show the beginning of the task? Yes. What do you need? The beginning of the task. I think, Elizaveta, you are more or less right. Let's calculate. So let's start. So which equation I can use to calculate U1? How can I will start with U1. Who can say me which equation can be? So I will start. So the sequence of calculations will be like that. Sequence. First, I will calculate U1. Then I will calculate L1, B1, S1, what else? LBS, well, that's all. Then I will calculate, so first step 1, then you won't believe me, I will calculate U2, L2, B2, S2, and then we will calculate, you will never guess, U3, L3, B3, U3. Okay, who can tell me which equation allows me to find U1? How can I find U1? There are a lot of equations, but look carefully at them. Which one allows you, or which two equations allows you to calculate U1? Yeah, exactly. If you look at the equation for Y, so step 1, look at the equation for YT. You know everything inside it. Just one U1 is missing. So if you look at equation for Y1, it says Y1, we know Y1, it's observed value. It's L0 plus B0 plus S minus 3 plus U1. And we know every term in this equation except U1. So in our case, it's, I don't remember, it is 101, yeah? 101 equals to 100 plus 2, 100 plus 2 plus, what is the seasonal effect? What is the seasonal effect? Who can find me the seasonal effect? Yeah, it's -1 because the sum of initial seasonal effects should be 0. And finally, we have U1. Yeah. From this equation, we have that U1 is is 0, yeah? Or maybe not. Yeah, it's 0. Okay? Any questions up to now? Okay. Now, who can help me to find L1, B1, S1? How we can find L1, B1, S1? Just 1 minute to you. You can do it by yourself. Yeah, first find B1. Just look at the equation for B1. What is the equation for B1? It's B0 plus beta times U1. And you know everything. So look at the equation for B1. Elizaveta is right. B1 is B0 plus beta times U1. And in our case, it's 2 plus 0.5 times 0. It's 2. Okay, B1 is calculated. From which equation we can find, let's say, S1 or L1? It's question to you. Who has found L1 and S1? Yeah, we just we just plug in into equations. We just need to find a good equation. Yeah, you are completely right. So we look at the equation for S1. It says S1 is just S minus 3 plus gamma times U1. And in our case, it's -1 plus 0.5 times 0. It's -1. In our case, we have 0 random noise. So basically, we copy old S and old B. Now look at the equation. Look at the equation for L1, and L1 is L0 plus B0 plus alpha times U1, and it's equal to, I think, 102. Okay, we now move on to the step 2. I think if you do step 2, you understand how to find the seasonal decomposition. I think there is nothing more complex in this process. Just I will change the order to do. Okay, we have found the first step values. How to find the second step values? So we have done step 1. We have found U1, B1, S1, L1. How can we find U2, B2, S2, L2? Do I need to find them or it's okay? Elizaveta says that it's clear, but anyone else? You just repeat the process. You just use the same equations. You calculate U2, B2, S2, L2, and basically you have a seasonal decomposition. Yeah. If you have no questions, then let's just go on to predictions. But maybe just who can answer what is the value of U2? Let's just check what is the value of U2, what is the value of let's who can tell me the values? U2 is 2. What is the value of B2? B2 is 3. S2 is and L2 is so let's just write the short answers. Who has found S2, L2, B2, and U2? Who is not lazy? Who has the same result as Elizaveta? Elizaveta, thank you very much for being active. I don't know why you are alone. Ah, what's wrong? Who has received the same results? Same, okay. Yeah, let's, okay, Sergey, thank you very much. Okay. So I think that we have mastered decomposition because basically you repeat the same process and so what do we need to have a seasonal decomposition? We need, so where we have started, let's recap a little bit. Where we have started. We have observed value of the process. That's okay. We have true parameters in this exercise. In real life, we have estimates. And when you have observed value, and estimated parameters by maximum likelihood, then you can decompose every y into and say, oh, this is a seasonal effect, this is a smoothed growth, and this is current. So BT may change, and you know current growth rate for every moment of t, you know error for every moment of t, strictly speaking estimated, yeah, because we have used true parameters. And when you use estimated parameters, then you have estimated seasonal effect, estimated error, estimated growth rate, and so on. Estimated seasonally adjusted LT hat, and you have estimates. But the process is exactly the same as with true parameters. The only thing that differs is that instead of writing true BT, you write BT hat. Instead of gamma, you write gamma hat. Instead of UT, you write UT hat, and so on. Instead of LT, where we use sigma here? Nowhere. We will use sigma when we will make interval forecasts. Sigma is a measure of variance. So when you make point predictions, it's useless. You are completely right, Anna. We are making point estimation. When we make point estimation, variance is useless. We don't need variance to make point estimates. But we'll go to the next question. If everything is okay with decomposition, let's move on to the next question. How we make predictions using ETS model. And here we will have, let's make predictive interval for Y101. And let's make interval predictions, and then here we will use sigma, because when you make point predictions, you don't need variance at all. Okay, to simplify, let's have the same parameters. Let's have the same parameters where they are. These are true parameters. And let's imagine that we have decomposed our process up to the last available information. So imagine that we have done seasonal decomposition. So if you can do 2 steps, then you understand that computer can very automatically do the decomposition for all process. So we have done seasonal decomposition up to y. Let's say the last observation is 100. Okay, so let's say that the last observation we have, and let's imagine that obviously I'm too lazy to just type 100 iterations, and let's imagine that the last step gave me something like, I need so imagine that the last step was beta 100 is 3 now, L100 is 400, S100 is 2, S99 is 1, S98 is -3, and S97 is -2. Due to random noise, the sum of 4 seasonal effects is 0 only in the beginning, and later it may a little bit deviate from 0. It will not it cannot be too far from 0. The sum of 4 consecutive seasonal effects is always 0 in a model without noise, but in a model with noise, because of this noise, this strict equation is satisfied that the sum of four seasonal effects is exactly zero in the beginning of times, and it's roughly zero later. Okay, any questions? So imagine that we have done seasonal decomposition. So we have decomposed every y into components. Okay, now my goal is to question, what is the questions? Find the point forecast for y 101 and find interval, let's say 95% 95% predictive interval for y 101. So we will find point forecast and interval forecast for our y. Any questions up to now? But you can just write no in the chat, or everything is fine, or be active, because otherwise I'm bored. If you have a good reaction, I'm happy, and if you are happy, you have greater grades. So think about your grades. If you are passive during a lecture, I'm unhappy. Yeah, I have found a good reason. Obviously, I'm not grading presence on lectures. You may see the recording. That's fine. I am not grading never presence on lectures, because I think it's a crazy idea. You may have other plans and so on. But if you are, just be active because it's fun. Okay. So let's move on to the maybe the students are always interested in the grades. Okay, let's speak about point forecast. Once again, we will use equations. We cannot use anything other. Okay, let's write an equation for the future value. Let's write the equation for the future value. What is the equation for the future value? It's, don't believe me, but it's L100 plus what? So what should I add to make prediction? Yeah, plus B100 plus what else? What do I have there? Yeah, plus, no, not S100, S90, because I have quarterly data. The effect, the seasonal effect of 101 is exactly as seasonal effect 4 seasons before, so I should add S97. And plus U101. The last term will be non-predictable. It will make future not completely predictable. I will predict the three first terms of this future value of phi. Three first terms, I know them. The last term, I don't know it. And I have no clues how to make inference about future error, future U101. I have assumptions that U101 is independent of what I know. So basically I have two parts. The first part is predictable. And so I have 400 plus 3 plus minus 2 plus U101. And so basically, given my information, I can say that Y101 is just 401 plus U101. And now it's very easy to make point forecasts and interval forecasts. So given my information, so that's important that it's given my information. Maybe I will even write something like this. What is the expected value of Y101? And then I will write here something like mass call F100. So this notation means using, so what does it mean? This notation, expected value of 101 vertical bar calligraphic F100. That means the expected value of future value of Y given all my available information. That means I have plugged in all B previous, all S, S100, S199, B100, B99. I have used all available. So this is, so what do I mean? Mass call F100 is just all available information up to time 100. From a rigorous mathematical viewpoint, this knowledge is described by sigma algebra, but we will not go into details. That basically a mathematical object to describe information. Maybe you have studied in bachelor course of probability, such thing, maybe not, but we will not go into details. Just intuitively, when we need to calculate expected value of Y given all available information, we just plug in all we know. And that's all. The calculations are simple in ETS model case. In some other models, it may be difficult, but for ETS models, calculations are very easy. Okay, so in my, so how can I calculate this value? Sometimes it's also denoted by expected value. Sometimes this index is put in the index of expected value. It's the same thing. So some authors like with F, this is conditional expected value. Yeah? This is conditional expected value. Okay, and now what is the conditional expected value? Finally, what is the what I have? When I have used every bit of information I have, I see that future value of Y is 401 plus something. That is unpredictable for me. U101 is a white noise process. More, it's normal. It's independent of what I have, because I have information about U1, U2, U3, U4, U5, and so on, but up to U100. I know everything up to moment 100. And U101 is independent of my information. So the best prediction for these U101 from my side is 0. I cannot predict it. So the conditional expected value will be 401 plus 0. Why? Because U101 is independent of my information, and so expected value of U101 given my information, this future noise, I have no clues how to predict it. So my information is useful in predictions of future error. So I just don't use my information in prediction of U101. So I calculate just ordinary expected value, and ordinary expected value of U101 is 0. Future noise is independent of my information available at time 100. Okay. Any questions about conditional expected value of future Y101 given my information? Yeah. We still need to estimate interval, but we have already point forecast. So let me write. So we already have a point prediction. Point prediction so how we denote point prediction? There are many ways. Either you write like this. So how to denote point forecast? You may denote point forecast like that. You may denote point forecast like with 100 near the expected value. And Hindman in his notes denote this like hat y, and here he writes something like 100 100. So oops. Yeah, everything is, and in our case it's just 401. So there are basically 3 ways to write this object. Okay, so now let's maybe calculate 2 steps ahead prediction, because we can do 1 step ahead prediction, we can do 2 steps ahead predictions. That's okay. Now let's move on to this 2 steps ahead prediction. That's very easy. Now let's do 2 steps ahead point prediction. Once again, I use equation for Y102. What is Y102? It's L 101 plus B101 plus S98, I think, plus U102. What do we do next? Who can tell me the equation for L101? What is L101? What is the first term in this equation? Yeah, Konstantin is right. The first term is just L100 plus B100 plus alpha times U101. Okay, the second term, what is B101? B101 is just, we have B100 plus beta times U101. Let's move on. Plus, what is the decomposition for S101? Is S... no, we don't. We have S. Sorry, we have S. We have S98 plus U102. and we just plug in everything we know. So we just y102, we just put everything we know. So it will be, I think, 400s plus what was B100 was, as far as I remember, it was, oh, I forgot it. It was 3 plus 0.5 U101. That is the first term. Plus, what else do we have? We have second brackets. It will be B100 is 3 plus 0.5 times U101 plus S98 was minus 3, as I remember, and plus U102. And finally, if I collect all the terms, I will get something that is very, very easy. It will be something like 403 plus U101 plus U102. Yeah, everything is right. Or am I mistaking somewhere? But I think that's okay. Now, who can make a point forecast? Who can read just the point forecast? What is point forecast? Point forecast. Hat Y102 given all available information up to time 100, or in more scientific notation, expected value of 102 given all available information up to time moment 100. This is equal to, who can read from what I have written? Yeah, it just, who else, or only Konstantin can? Konstantin is right, but I'm just wondering whether everything okay, or everyone is lost, or should I go faster or stop a little bit? Yeah, the answer is right. It's 403, but my question is, it's okay for Nikita. Okay, if it's not, if you are lazy to type I'm lost, it's not okay, then you are lazy. I just need some feedback to understand whether I can move on or should I stop. Okay, points, I hope point forecasts are clear. Now let's move on to interval forecasts. So basically, what do we have? What will be responsible YU101? It's not 0. No, it's not 0. I don't say it's forecast. Forecasted value are 0. Maxim, you are not right. Not U101 is not 0. Point forecast of U. So once again, let's work with so Y. So let's stress that U101 is not 0. Is not 0. It's nothing. But I predicted as 0 because it's a white noise process, and I have no information on future value of U, because we have basically what we have done in ETS model. We have decomposed YT. So what we have done, what is the logic behind? We have decomposed Y101 into two parts. predictable and not predictable. Predictable is L100 plus B100 plus S97, as far as I remember. Just and not predictable U101. So this is the logic of ETS model. We have decomposed it. I do not pretend that U101 will be 0, but my prediction, my best prediction for U101 is 0. Yeah, I will be wrong there, but I can do nothing. I have completely predicted what is predictable, and what is unpredictable I cannot do, because in my assumptions I have stated that these random noises, they are independent, and I have information about time up to 100. I don't have information about 101, no information about U101. I can, using these equations, I can figure out what is my prediction for L, for S, for B, but not for U101. So what do I say is that expected value of U101 given all available information up to time 100, this value is 0, but not U itself. Okay, Maxim? I'm not saying that U101 or U102 is 0. They are not 0, but their predictions at time 100 is 0. Okay, now let's move on to interval forecasts. Interval forecasts. With interval forecasts, we just calculate variance. Let's calculate conditional variance. Conditional variance. Let's calculate conditional variance. We calculate variance of Y101 given all information we have, given F. This is calligraphic F that denotes just the all information available up to time t. So it's we have decomposed y, future y into two parts, 401 plus U101. First part is completely known. Given my information, I can just plug in part of future y. So the basic idea when we forecast with ETS models, that we plug in part of YT that we can calculate, and we basically think about part that we cannot calculate exactly as a random variable. So what is the distribution of U101? Who remembers? We go up, we go back, sorry, a little bit, and we see that U has normal distribution. It has normal distribution with with sigma equal to 2, as I remember. Yeah, sigma is equal to 2. So basically, I know that variance, so 4001, does it influence variance or not? This constant, does constant fixed value, does it influence current value? No. So basically, I omit it. So basically, I forgot about 401. Now, because my information is useless in forecasting U101, U101 is an unpredictable part of Y. So here I just omit my information. Oops. Now my information is useless. And this variance is 2 squared. It's just sigma squared. Okay, so if I summarize my findings, then I see that U100, so I see that Y101, given my available information, has a normal distribution with mean 401 and variance 2 squared. So, summary. What do I know about future value of Y? Future value of Y is normally distributed. Given my information, future value of Y, from my point of view, is normally distributed with mean 401 and variance 2 squared. So now if I like to construct, let's say, 95 predictive interval, you remember that critical value, maybe you remember the critical value that is 1.96. Yeah. And then the predictive interval is very easy. I just take 401 minus 1.96 squared value of 4 up to the variance is 4. Yeah, this is variance. And the interval is symmetric because we work with normal distribution. Now we have calculated one step ahead predictive interval. If you have any questions, just don't be shy. If you have no questions, then let's calculate 2 steps ahead forecasts interval. We have already calculated point forecast, but let's calculate Y variance is equal to 2. Variance is equal to 4, Y2. Variance is equal to 4. Why, Igor, could you explain your question? Because I don't get it. In my writings, variance is equal to 4, and in your question, you ask why variance is equal to 2. It's equal to 4. Because variance, because it's given. We started that true parameters of our model are, we have true parameters of our model. So we skipped the step of maximum likelihood estimation. We just said we have estimated parameters, 9 parameters. 9 parameters are beta 0, L0, S0, ta 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 ta. Sigma is a parameter of the model. It's estimated by maximum likelihood. Okay, any more questions? Igor, are you happy with the answer? Igor is not happy, probably. Um, so we will discuss how parameters are estimated, but for the moment, I have assumed, let's assume that we know true values of parameters. We will discuss that later, probably not today. But so there are 3 actions that are really executed. First action is 9 parameters are estimated. We have real data, we have model, we have algorithm that is called maximum likelihood, and computer says, oh, if you use maximum likelihood for that data, for that initial, for that time series, for that plot, you estimate, and it says, oh, your 9 parameters are. Then the step 2, we have done it. How to decompose observed y1, y2, y3 into effects using estimated parameters. That's very easy. Just use equations. Just a moment. When we calculate predictive intervals, we just use standard deviation, but not standard error, because because we always use standard error, or we always use standard deviations, because we just need to specify for which random variable we have used. We have especially calculated the variance of what we need to estimate, and so we use this square root of variance. 2 steps ahead, no, it will not be like this. So let's move on to 2 steps ahead. So first answer for Konstantin, that no, that's not 1 point plus minus 1.96 times 2, not times 2. The factor will be different. The second answer is Victor. When we calculate, we just use standard deviance, but not standard error. We always in statistics, you do. So let me write a big formula. When you like to forecast, when you like to estimate, forecast, if you speak about, you always have some. So if you'd like to forecast what is a elephant is in interval like expected value of elephant minus 1.96 square root of variance of elephant up to, you always use this logic. This is just a bad terminology in statistics. So normally you just used to say standard deviance, standard error, they are different. That's a crazy terminology, standard error, standard deviation. You always need to understand what you are forecasting. For example, if you are forecasting in base statistics course, you have forecasted, you have estimated sample mean. So you always do like this. You always do some, for example, if so mu in statistics is estimated by so when you speak about y bar sample mean, then the standard deviation of y bar is just called standard error. That's bad terminology, but the formula is always simple. If elephant is normally distributed, then The confidence interval for the elephant is like that, or maybe elephant is too big. Okay. So let's move on to the 2 steps ahead forecasts. What is our summary? Let's write summary for 2 steps ahead forecasts. What is our summary? Y hat is what is the best prediction? So not yet, we are not ready. So what is my formula? I will just copy for 101. Yeah, here is the formula. I need this formula. U102, we have proven that. Let's move on. Let's move on to 2 steps ahead forecasts. And now we observe that expected value of Y102 given my available information is just 403. And by the same logic, I see that variance is just, sorry, of 102, yeah. It's just variance of 403. I will just copy all I have. And finally, I will have 403 plus U101 plus U102. Once again, I have decomposed future value into 2 parts, completely predictable and unpredictable. I remove 403 because it's completely predictable, and yeah, Konstantin is right. There should be 8 there in variance. Yeah, I will remove 403, so I just remove it. And my because I remove 103 because it does not influence variance. I remove my information F100 because it's useless in predicting future Y101 and U101 and U102 because U102, U101 are unpredictable part of my process. So I replace this with just, I remove my information because it's useless in predicting U1, U102, and I remove 403 because that's a constant. Now it's the variance of a sum of uncorrelated random variables is a sum of variances. So it's 4 plus 4, it's 8. And now I have summary. I will just copy summary from U1 from 1 step ahead forecast. And now the expected value has changed and variance has changed. And I think that's all. We can make 95 predictive interval. Everything is already calculated. The structure is exactly the same, but we just replace 4 with 8 and 401 with 403. Okay, any questions with 1 step and 2 steps ahead forecasting? The right answer is provided by Konstantin. Sorry, I'm wrong. A normal elephant. It's not every elephant. Normal elephant is in. Okay. I think we have 9 minutes. It would be a little bit tough to write likelihood functions of ETS model because it requires normal distribution and so on. So I will skip this step, but versions of ETS models, that's fine. We can switch off some components. For example, we have discussed ETS AAA. That means, what does it mean? The letter A, what does it mean stands for? Error, the first letter, E, error, A, is additive. Then trend, the second letter, is additive. Third letter, seasonal effect, is additive. What versions are possible? For example, we can switch off some components. We can switch off some components. For example, we can consider ETS ANA model. What does it mean, ANA? That means error is additive. Trend is absent. No, maybe no trend. Maybe additive. Maybe it's better like this. Additive error. ANA model looks like this. So ETS ANA model equations are simplified by one assumption: BT is just always 0. We switch off the trend. Yeah, well, that means additive error. Our original model abbreviation was acronym was A, additive error, A, additive trend, A, additive seasonal component. So every component is additive. Or we can switch both components. For example, I can consider a very, very simple model that was born in, I think, 70 years ago, ANN model. It has additive error, no trend, no seasonal effects. That means I replace the corresponding equation just by ST equal to 0. So I can switch off some components in the model. What is additive? The second question, if there are additive, there should be multiplicative. Yeah. So you can find all the equations in the corresponding chapter. So if you just, so let me write one equation for multiplicative model. So let's consider something like ETS MMMM. So everything we can consider multiplicative components. I will not write all the equations. You can just find them in Hindman's book. I have links provided in the beginning, but I will just write one equations to compare, just one equation. So if you consider ETS AAA, so basically you have YT is L1 L T minus 1 plus B T minus 1 plus S T minus 4 plus UT. In multiplicative model, that changes a little bit. You will have multiplicative effect here, multiplicative effect there, and multiplicative effect for UT like this. Or you can combine effects, something like ETS MAM will have something like MAM. What do I will have? Oh, I will have additive additive trend plus times ST times 1 plus UT. So basically that is ETS NNNNN is not used. We always have error. So I have considered, so NNNNN, we do not use such a model because without error, it's something predictable. We do not believe that. So you may think from a formal point of view, you have no error, you have no trend, you have no seasonality. For ETS NNN, you will have something like, what do we have? What do you will have? You will have L. Yeah, you will have something like, yeah, you will have just a, yeah, you will have just a horizontal line. You will have LT is equal to LT minus 1 plus no B plus no noise, and YT will be equal to LT minus 1, no seasonal effects, no trend, no noise. So we do not use such a model because it's wrong for every time series possible except 555555555. But yes, the structure is yeah, is just like this. We never use it. We never use it. It's too simple. But yes, ETS NNN will be basically. And I think I have some metrics. So let's say about metrics, maybe is the last thing that is like lecture. When we have estimated some concurrent models. So for example, you have estimated AAA, you have estimated. So let's last topic. I think it's enough. There are no deep theory. I will go into train test split. I think you have already done it during the first class. So I think it's very easy. When you have some concurrent methods, so for example, you have estimated AAA model, you have estimated MAM model, and you would like to compare them. You would like to say, oh, and which one should I use for real prediction? I have two models, both with seasonality, one with both with trends, but one with multiplicative effects and one with additive effects. So what do we do? So we have our time series y1, y2, y100. So basically, first, to evaluate the quality of models, we split our time series into two parts. The beginning is train part, the end is test part. I think that's easy. So the beginning is training sample, something like y1. What is the proportion? Normally, something like 80 to 20%, or 90 to 10%. There are no strict rules here. Basically, I have 80 observations in my training sample, and I have 80 observations in my training sample and 20 observations in my test sample. Okay, the train test split is very easy. That's okay. Any questions about train test split? Okay, so I estimate my my alternative, my models using training sample. Imagine that I have two models. There are many more models, but let's assume that we have estimated two models using training sample. Then I do predictions for test sample, because I can predict using models. And then I need to evaluate them. What are the possible metrics? One simple metrics is just mean average error, mean absolute error. That is just the sum of, that will be, I have 20 testing observations, so it's just the sum of something like y t minus hat y t, like this. In my case, it would range, the time t would range from 81 up to 100. This is mean absolute error. What are the possible metrics? Do you know? How can you compare? What other indicators do you know? Mean absolute error, what else? What other indicators do you know? No, OLS, it's a technology, but but the comparison goal is mean squared error. OLS is a method. It's not, you can compare models using, mean squared error. What is the mean squared error? You just replace here in the nominator, you have squared value here. Or you can compare, this is mean squared error. Mean squared error. What else do you know? Mean absolute error, mean squared error. What else? Yeah, you can use mean absolute percentage error. Mean absolute percentage. So here we divide by YT. Yeah, we may compare in percentage. And the last one, probably the most popular, there are some problems with mean average percentage error, because if YT is very small, for example, if YT happens to be 0, you have infinite mean average percentage error. So the main problem with it's very good, because mean absolute percentage error, you don't care about units. You may go from measuring in rubles into measuring in hundreds of rubles or millions of rubles. Mean average percentage error does not is not influenced by scale. But the problem with mean average percentage error, that it's just very sensitive to 0 value of y. And there is a symmetric version of this indicator. Symmetric mean absolute percentage error. Here we divide not by ST, but we divide by ST, where ST is just, sorry, we divide here by ST, and ST is just mean between absolute value of YT and absolute value of forecast. So basically, these are four popular measures how to compare two models. Yeah, like that. And I think that's all. So how we compare models? One way is to just divide my sample into train test split, evaluate models on training sample, forecast on test sample, and compare them using one of these four metrics. I think the last one is more and more popular, but you can encounter these four metrics. They are quite popular, all the four. Okay, that's all for today. If you have any questions, then yeah, I will send lecture notes today, but later I will add pictures. With pictures, it's a little bit difficult because I need to just work a little bit, but with just text, that's fine. Today I will send, that's not a problem. With pictures, it's a little bit, it takes time, but that's all for today. Basically, thank you for coming, but please be active. I don't grade presence during lectures. You are free to listen to it afterwards, to just read notes and read books. But if you are present, please just say, oh, no, that's too fast. No, that's too slow. No, I don't understand, and so on. Because your action is, I miss it very much. Okay, thank you. If you have any questions after the end of the lecture, you can post them in the chat. Me or Luba, we will try to answer them. So thank you for coming. Bye bye. Have a nice evening. See you next time.